Hello everyone, my name is David Battelle and I'm here today to present on vacuum trains and Elon Musk's Hyperloop in particular. This project is unlike many of the others that have been given so far in this engineering class because it speaks of an idea that is almost entirely unproven. Even the most advanced vacuum train projects are still in the design stage. However, it is an intriguing idea and may possibly represent a portion of the future of mass transportation technology. However, before we examine such experimental technology as the vacuum train, it might be good to look at previous innovations that have allowed very high-speed mass transit. I assume you've all heard of the standard maglev train, which is a train that manages to magnetically levitate itself over the track using superconducting magnets. This sort of design is made to solve one of the major problems in attempting to get high velocities, the fact that wheel friction becomes very large at speeds over several hundred miles per hour. And with magnetic levitation, there is no contact between the wheels and the ground. Meanwhile, vacuum trains are intended to optimize in the opposite direction. They remove the atmosphere from the problem altogether by having a train travel through a vacuum. Considering that functional maglev trains already exist, it's interesting to consider that the concept for pneumatically driven transport has been around for actually significantly longer. For example, in the beginning of the 20th century, there were many tube systems that were created to carry around small parcels, some of which can, for example, still be seen in banks. Furthermore, Jules Verne wrote about high-speed pneumatic trains in an 1863 dystopian novel, Paris in the 20th century. It's worth comparing differences in design between maglev and pneumatic trains. For example, both of them try to deal with the wheel friction problem. Maglev trains, obviously, that is their major purpose. Whereas pneumatic trains often have an air cushion that they ride on, which, even though it's not as effective as magnetic levitation, significantly reduces the amount of wheel friction that would be caused by actual wheels. Each one also has its pros and cons. For example, pneumatic trains don't involve superconductors, and thus they don't have to deal with exceedingly sub-zero temperatures. Furthermore, they don't have powerful magnetic fields holding them up, so shielding isn't necessary to protect passengers' credit cards and pacemakers. And also, energy does not have to be expended to keep the system cooled. But there are also many problems with it, including the fact that the majority of designs require a hard vacuum, as in an extremely low concentration of atmosphere, and which takes a lot of energy to maintain. Vacuums are also very expensive over long distances that any reasonable train system would have to cover, and there often are very large problems with the designs if pressurization is actually ever lost due to natural disaster or mistakes or terrorism. At the moment, the most realistic and well-known pneumatic train design is almost certainly Elon Musk's Hyperloop. You probably recognize the name Elon Musk. He is the billionaire entrepreneur who founded Tesla and SpaceX, on which we had a presentation earlier this week. However, the major difference between the Hyperloop and most other pneumatic train designs is the pressure at which it's designed to operate. The Hyperloop, its current design allows for it to have pressures of approximately 1,000th of normal atmospheric pressure, which, even though that sounds like very little, most pneumatic train designs would fail because that is enough air to build up a sizable resistance, and so they wouldn't be able to go even close to as fast as maglev trains. However, the Hyperloop uses a powered compressor at the front of the train and a very large fan as well, kind of looks comical actually, to suck in air and then push it out at the back of the train to give it an additional boost and to prevent air from building up and causing resistance at the front of the train. This solves many of the problems from the previous slide, because if you noticed, the major detriments to pneumatic trains were that a large-scale vacuum is exceedingly difficult to maintain. Now let's examine in depth the technical specs of the Hyperloop. It's designed to connect San Francisco and Los Angeles, and its theoretical top speed is 760 miles per hour, which is significant compared to the Shanghai Maglev, the world's fastest train, which moves at a maximum of 270 miles per hour. It would accelerate using linear accelerators of similar designs to Tesla's motors, which we mounted in the walls of the tube. This is important because it means that, since the pod does not need to carry its own power source, it can be much lighter and thus accelerated with much less energy. All the power that would be necessary to get the pod up to speed would be generated from solar panels mounted on the top of the tube, making it energy neutral. However, many people have expressed doubt in the safety of the system, as is natural with anything that moves at 700 miles per hour and carries passengers. One of the major safety concerns is the chance of earthquakes in California. The white paper that Elon Musk wrote about this topic allows for certain safety calculations which suggest that it would be flexible enough to survive any major earthquakes. However, he does not account for the possibility of a total failure of many of the pylons, which might be catastrophic. In general, however, a loss of pressure or stranded capsule or any other disaster scenario leads the pods to, and I quote, deploy their mechanical braking systems. I have personal doubts about this, about any mechanical brakes that can stop you from moving at 700 miles per hour without other types of disaster, but maybe I'm just a doubter because his paper seems to be very well written. He seems to have covered all the options. Many have doubted the feasibility of the Hyperloop system. It's currently being tested, and the construction of a 5-mile proof of concept test track begins next year. Its estimated cost, according to the white paper, would be $6 billion, which is significant, obviously, but it's pretty cheap compared to the estimated $58 billion of the California high-speed rail system, which is currently being built and would carry people over the exact same distance and route. There is recently a new startup, Hyperloop Technologies, which has been founded by one of Musk's associates, Shervin Pishavar, and which has raised significant portions of the necessary budget for the project. It is also currently hiring, and an interesting trivia fact is that much of their funding actually came from good investments in the taxi company Uber. The more you know. In conclusion, even though this may seem like some kind of futuristic sci-fi technology, I think that it is feasible in the current day, not the least of which because Elon Musk has managed to complete several ambitious projects which most other engineers doubted, such as Tesla and SpaceX. If the white paper he gave is accurate, and if all the technical problems can be solved, it seems like this is a very feasible solution for the future of high-speed transportation.